Today we are talking about synthetic division, and I can't stress enough how important these notes are. Easily half the test is reliant on your understanding and ability to do synthetic division. So pay close attention. It's not a hard process. It's just going to take you a few problems before you really feel like you're getting what I'm doing here. Before we do synthetic division, I'm going to throw it back to when you very first learned division back in elementary school and go over some basic terms. And just so we have an example to look off of, let's say we have the problem 10 divided by 2. Hopefully you know that that is 5. The numbers, each one of them is in a specific spot and it has a specific name based on where it's at in the problem. The 10, we refer to this number as the dividend. Divided by the 2, we refer to as the divisor. Equals 5 is the answer to the problem, of course, but the answer to a division problem has a very specific name and it does not start with the letter D. Does anyone remember what this is called? Harneet? Quotient is correct. Very good. I'm going to add just some very quick, simple definitions under those. Dividend is the number that you're taking and you're going to be dividing it up. It's the number being divided. Divisor, which I will talk about a lot, is the number you are dividing by. Quotient is the easiest definition. It's the answer. Of those 3 words, I'm going to say divisor a lot, so it's just helpful to be aware of the 3 terms. Next section, this is an important concept that's going to come up in every single problem. Interpreting a remainder. Again, I'm going to take it back to a very simple problem. 8 divided by 2 equals, should already know that's 4. And you know this because 8 is divisible by 2. It divides very nicely. So if we were to divide this out, say we didn't already know the answer, this is what it would look like. 8 divided by 2. 2 goes into 8 4 times, which gives us 8. And when we subtract, there is 0. 0 is our remainder. R0. Since we can divide this nicely, this means 8 is divisible by 2. Again, ideally, you're already aware of that fact. That just means you can divide 8 by 2 and it's nice. You get a nice answer. Now, more importantly is the conclusion you can make based off of that, and this is what you're going to have to know for today's notes. R equals 0 here. Our remainder is 0. Since 8 is divisible by 2, 2 is a factor of 8. Again, hopefully you're already aware of that. I could say, what are the factors of 8? And you could tell me 1, 2, 4, and 8. Let's juxtapose that with a problem that does not work out as nicely. 8 divided by 3. You already know that's going to be a not nice decimal. If we divide that, we have h divided by 3. 3 goes into h 2 times. 3 times 2 is 6, and when we subtract, we still have 2 left over. So that gives us a remainder of 2. Which is not what we want here. We want no remainder. Remainder 0. This means a is not divisible by 3. You can't divide 8 by 3 because it doesn't give you a nice whole number like when you divide by 2. The conclusion to be made, and again, the big important thing to understand for today, when your remainder is not 0, you get a number for your remainder besides 0, then it's not a factor. 3 is not a factor of 8 because you can't divide 8 by 3 without getting a remainder. At the end of each problem that I'm going to do here today, I will make a statement, one of these two. If my remainder is 0, I'm going to state that it is a factor. If my remainder is not 0, I'm going to state that it's not a factor. You should be able to interpret that for yourself. That's the goal. Let's look at an actual Algebra 2 style problem, synthetic division. Divide the following polynomials using synthetic division, then interpret the remainder. So let's label these positions again according to the vocab above. The first term is the dividend, and the second term is the divisor. And then we're going to find the quotient in a moment. So our very, very first step here, set divisor equal to 0, and solve. I guess I'll put a star there because I'm going to use steps in the next part, and that's going to get confusing. So that's the very, very first thing you do. So our divisor is x minus 5 equals 0, and we just got to solve for x. So we'll add 5 to both sides. X is 5. For the types of problems that we're going to be doing in this class, you can just do the shortcut, which is look at the divisor and flip the sign. If this were a far more complicated divisor, we would need to do this every time, but we're not doing anything complicated in this class. So look at it and change the sign, you'll be fine. It's a negative 5, I'm actually going to use positive 5. You'll do this every time. If it's negative, turn it positive. If it's positive, turn it negative. The reason why I just showed you over here. That's the logic behind it. Let's set up the problem. First thing I want to do is write out the dividend, but I'm going to really emphasize that one in front of the first term. We're going to need that. So we have 1x squared. And I'm going to intentionally exaggerate the spacing here because I'm going to be doing a lot of explaining. Plus 3x minus 40. Synthetic division, the first thing you're going to draw, and it looks a little weird the first time you see it, it's a little backwards L, and you put the divisor in it. Our divisor is plus 5, or just 5. And then we're going to take just the coefficients from the polynomial above, so the numbers in front of the x's, and we're going to use those. 1, 3, negative 40. Last thing you need to start the problem, you're going to draw a black line. This is your workspace. And now we're going to do the problem. So this essentially is the synthetic division problem right here, is just the numbers. Very first thing you do is you take the first number, which is 1, and bring it down and write it under the black line. So step 1, bring down first number, not the divisor, but the first number after that. Next step, I'm going to draw an arrow from the 1 to the space under the 3. So about right there. We're going to take this 1 and we're going to multiply it by the divisor. So times 5. 1 times 5 is 5. So that was step 2. Multiply by the divisor. Step 3, we're going to add down. So the 3 and the 5, we're going to add those. Step 3, add down. 3 plus 5 is 8. From here, you repeat steps 2 and 3 until you run out of numbers. So I'm back to where I was with the 1. So I'm going to do this process again. So we're going to do 8 times 5, which is going to give me positive 40. And then I'm going to add down. Negative 40 plus 40 is 0. That's the synthetic division process. Any questions over the steps before I create my answer? Okay. Remember, we started with polynomials. We have to end with polynomials. So just ending with 3 random numbers, we're not done. We need to put the answer back together, if you will. So each one of these has a place value. It represents a specific spot in the polynomial. The number at the end is actually the remainder. From here, we're going to build up the polynomial. We're going to start with the smallest term in the polynomial and work our way up. So the smallest term in a polynomial is the constant. It doesn't have an x. So this 8 here is a constant, meaning it has no x on it. And in the next few problems, I'll just write no x underneath so that I know it doesn't get an x. The next term, the next place, is just x, or x to the first, however you see that. If I had more numbers, I would keep going with the exponents. So the next one would be x squared, x cubed, x to the fourth, and it would just keep going up from there. But this is all that I have, so I'll stop there. Next, we need to write out the answer. The answer has a name. It's technically a quotient, but specifically for this kind of problem, we call it the depressed polynomial. We're going to put our terms back together, and I'm going to start with the first one. My first term, 1x. I'm not going to write to the first. You're welcome to do that if you want. Next term is an 8. It's positive, so plus 8, and it gets no x on it. So 1x plus 8 Or you can drop the 1 in front and just say x plus 8. I always prefer the second one, but that's just me. They're both correct. There's no remainder here, so that's a good thing. So this is the first part of the problem. We've divided, we've found the answer after synthetic division, then interpret the remainder. So we need to make one of these two statements. We did not have a remainder, so we're going to write this. R equals 0. Now, when we did this earlier, we said that 2 is a factor of 8. The divisor is a factor of the dividend. So we're going to write the same thing. X minus 5 is a factor of our original polynomial, x squared plus 3x minus 40. X minus 5 is a factor of x squared plus 3x minus 40. That's interpreting the remainder. Questions on this first problem before we do another one? All right, we got 2 more. I'm obviously going to not explain nearly as much as I just did, so these will go significantly faster. Number 2, 3x cubed plus 5x squared minus 5x minus 8 over x plus 2. Reminder, fractions are still division. 8 over 4 is still 8 divided by 4. They're the same thing. So I'm going to write this out as the normal division problem. We have 3x cubed plus 5x squared minus 5x minus 8 divided by x plus 2. We're going to set up the synthetic division. The first thing we need to do is mess with the divisor. It's a plus 2, so I'm going to change that and turn it into a minus 2. So we have our little backwards L with the negative 2 inside. And then I'm going to take all the coefficients, 3, 5, negative 8. Now we can get started. First step, take that first number, not the divisor, but the first coefficient, 3, bring it down. And this is the number we're going to start doing math with. From here, it's multiply, add, multiply, add, multiply, add until we're done. First, multiply 3 by the divisor, which is negative 2. 3 times negative 2 is negative 6. Be careful with those signs. After that, we're going to add down. 5 plus negative 6 is negative 1. And we repeat. Negative 1 times negative 2 is positive 2. And then we add down. Negative 5 plus 2 is negative 3. And then we repeat again. Multiply by negative 2. Negative 3 times negative 2 is positive 6. And then we add down. Negative 8 plus 6 is negative 2. Questions on the math, on the steps. Do these problems slowly and carefully. As you can see, there is a lot of room for error, especially when negatives are involved. Mistakes are very easy to make here. Now that we have our answer, we can build the polynomial back for our depressed polynomial. Start at the end. We know that the last number is the remainder. And then we'll build the polynomial. We start with the constant, which gets no x. Negative 1 gets an x to the first. 3 gets an x to the second. And then we'll stop there because we don't have any more numbers. Now we can write out the depressed polynomial, which I will just call the DP for short. Put it back together, starting with the first term. 3x squared minus 1x minus 3, no x on that. When you have a remainder, you do have to put that in your answer, just like we did that on the front with the simpler problems. However, we are not just going to write r negative 2 at the end. There is another way to write remainders, and it's as a fraction. So that's the way we're expecting you to write it in this unit. I don't care if this is positive or negative. You're going to put a plus first. Plus, and then the negative will be part of the fraction. You'll put the r on top, so negative 2, whatever that is. And then on bottom, you're going to put the divisor, the original divisor, x plus 2. So I'm going to add just a little note over here. This is a remainder over divisor. Since we got a remainder, that means this divisor is not a factor of the original polynomial. When we divided, it did not divide nicely. So we'll make that statement. R was not 0. We got a remainder that was not 0, which is not what we want. Therefore, the divisor, which is x plus 2, is not a factor of the thing that was being divided, so the polynomial above. 3x cubed plus 5x squared minus 5x minus 8. It's not a factor. You can't divide it nicely. I've got one more problem. Questions on number 2 before we move on? There's one more thing I have to show you, and this is something that's very sneaky. You have to look for it every single time. 6x to the 4th minus 8x cubed plus 12x minus 14 divided by x minus 2. You're going to see why in a moment, but I'm going to write it again. 6x to the 4th minus 8x cubed, and I'm going to stop. What is supposed to come after x cubed? X squared. It's not there. Reminder, each number represents a place value. If one of those numbers is missing, we have to still put something there to fill that space. So since we don't have an x squared, what number are we going to put in its place? We don't have it at all. 0. 0 is a very convenient placeholder. So after the negative 8x cubed, I'm going to put a plus 0x squared just to fill the space, fill the missing spot. And I literally added nothing to the equation. So I didn't change the equation by putting this there. And then I'll continue. Plus 12x minus 14 divided by x minus 2. From now on, now that you've seen it, every time you do a problem, always check for this. Make sure that whatever your highest number is, everything after that is included in the problem. If you're missing a place, it's going to shift your problem completely. Your numbers will be wrong. Now that that's taken care of, we can set up the problem. First things first, change the divisor. This is a negative 2. I'm going to turn it into a positive 2. Now we can set up our problem. We're dividing by positive 2. We're going to take our coefficients from above. 6 minus 8, 0, 12, negative 14. And then we'll do the math. First, take that first coefficient 6 and bring it down. From here, we multiply, add, multiply, add. Multiply by positive 2, and we get 12. 6 times 2 is 12. Then we add down, bless you, negative 8 plus 12 is, careful, positive 4, not negative 4. And then we repeat. 4 times 2 is 8, and then we add down. One of the most common mistakes is made right here. 0 plus 8 is 8, not 0. 0 plus 8 is 8. Then we multiply again. 8 times 2 is positive 16. And then we add. 12 plus 16 is 28. Repeat one more time. 28 times 2 is 56. And then we add for the last time. Negative 14 plus 56 is positive 42. And I'm out of numbers. From here, we build our answer. The very last number is always the remainder, r. The rest of the terms are in the polynomial, starting with the lowest term, no x on it. Next term gets an x, or an x to the first. Next term gets an x squared, and the next one gets an x cubed. And finally, we can build our answer, the dp, the depressed polynomial. Starting with the first term, we have 6x cubed. 4 is positive, so we'll put a plus in front of it, plus 4x squared. 8 is also positive, so it gets a plus 8x. 28 is positive, plus 28. No x on that term. Don't forget there is a remainder, so it has to go in the answer. Plus the remainder number, r, which is 42, goes on top. And then the full divisor from the beginning of the problem is x minus 2. That goes on bottom. That's our dp, our depressed polynomial. Once again, since we got a remainder, that means that this is not a factor. This does not divide nicely. So we have to make a statement. R does not equal 0. Therefore, our divisor, x minus 2, is not a factor of what we were dividing in the first place, that original polynomial. You don't have to include the 0 when you write this down. 6x to the 4th minus 8x cubed plus 12x minus 14. That's our interpretation of the remainder.